Okay, let's look at Archimedes' principle. Archimedes' principle is the idea behind buoyant forces. That is, when you get in the swimming pool and you're swimming around, you feel a lot lighter than you actually are. And that's because the water is actually pushing up on you with this buoyant force. And that buoyant force we'll find is described by Archimedes' principle. So a submerged object experiences a buoyant force. And Archimedes' principle describes what this buoyant force is equal to. It's equal to the weight of the displaced fluid. So if I have an object that is submerged, it has a certain volume, and it displaces that volume of water. So our volume of our object is equal to the volume of the displaced liquid, water in this case. And the buoyant force is equal to the weight of that displaced fluid. So I could say then that our buoyant force is equal to the mass of the displaced fluid times g. That's what Archimedes' principle says in short. And so the buoyant force then, since I know that density is equal to mass over volume, then I can say that the mass of the displaced fluid is equal to the density of the fluid, water in this case, times the volume of the displaced fluid, which is going to be the volume of the object. Right? That's just another expression for the mass that takes into account the definition for density and also this idea that the volume of the object is equal to the volume of the displaced fluid times g. Right, so that's the buoyant force then is equal to the density of the fluid times the volume of the object times the acceleration due to gravity. And that buoyant force is upwards. And so it's dependent it's dependent on the volume of the object. The bigger your object is, the greater the buoyant force will be. Now, this also holds true when the object is only partially submerged. In this case, the volume is only the part of the volume that is below the level of the fluid. So here, we would only, to find the buoyant force would only equal, let's say if just half of the volume was submerged, it would equal to the density of the fluid times the volume of the object divided by 2, because that's the part that's actually underwater, times g. We can also say that since it is not fully submerged, that the buoyant force must equal the weight. And you'll see this come up in some of the old exam questions, and I think in the homework as well. So we can say that because it's not fully submerged, that it's equal to the weight. You can say that if it looks like this as well, like if the object is floating in the middle of the liquid, not accelerating neither up or down, then we can say that the buoyant force and the weight are equal. However, you cannot say that if it's sitting on the bottom of the container. In this case, you still have a buoyant force and you still have a weight, but you know that the buoyant force in this case is less than the weight, or at the very least, or yeah, it's less than the weight. And that's why it's sitting at the bottom and not sort of just free floating in the middle. Okay. I have a couple of clips I want to show you. First, let's just watch this. This is a brief explanation of buoyant force by Bill Nye, and it's pretty simple, but this is a pretty simple principle, so you can watch that. Okay, so that's the Archimedes principle. This comes up a lot when you're measuring body fat. It's kind of difficult to actually measure the body fat of a human being because we're very irregularly shaped, and you can sort of take rough estimates with calipers where they pinch your arms and they see how much body fat you have. But to really get a good measurement of the amount of body fat, they need to measure the density of your body. And by looking at the density of your body, you can figure out how much body fat and how much muscle mass you have. So the way they do that is first they'll take a person and they'll put them on their scale. and they'll find what is their mass. Right? That's pretty easy. And then you take a person and you sink them, you put them on a scale. This is a scale. You lay that person on a scale, submerged underwater. And then you measure their mass again. And this mass is going to be less. And so you can find the buoyant force is going to equal to the actual weight of the person minus the apparent weight, which I'm going to call AW. Because the apparent weight is what we measure here, and this is our actual weight. The apparent weight is going to be less than the actual weight because you're submerged and you have this buoyant force pushing up. So I can find my buoyant force in this way. And then once I have that buoyant force, I can say that the buoyant force is equal to the density of the fluid, which you know, times the volume of the object, which you don't know because it's kind of difficult to find the volume of a human being, times G. And since you know this, and you know this, and you know this, then you can solve for the volume of the human body, whatever human that is. Now, it's easy to measure the mass. Now you have the volume, so it's pretty simple now to find the density of your body, which is going to be the mass divided by the volume. And voila, you have the density of your body, a nice measurement of your density. And they use tables. It's actually slightly more complicated than this, but not terribly more so, to actually determine what is your body fat percent. All right, there's a clip here of some people doing this. It's actually fairly interesting. I don't know if any of you have ever had it done. Probably not, but you can watch that here. And here are some questions that you'll see on the online quiz. You can go ahead and work through them here. Should be able to work through those now.